Dear viewers, welcome to my channel Creative World. At first I have to introduce you about the series board. You can see a series board. It have a series socket. Middle on is series switch. You can see under right side, that is AC socket. At first I connect the AC cable with the series socket of the series board. You can see the light have to be enlightened. That means the circuit of the induction cooker have to be shorted. You see I push the power switch, but they don't have any power and the series light have to be enlightened. Let's see, we check it. At first let's open the screw of the induction cooker. Dear viewers, I opened the whole screw of the induction cooker. Now just open the upper cover of the induction cooker. At first I have to remove the panel board cable from the PCB board. Now let's open the screw from the heating coil. We remove the screw from the heating coil. Now we opened it. Now gradually we disconnect the heating sensor from the PCB board, and now the fan, cooling fan. We can see the PCB board is connected with the back cover. Now we need to open the screw from the back cover. We know it is the power part of induction cooker, so now we must check the rectifier diode. We need to open it because when it is connected with the PCB board, it don't show us correct value of it. So now we need to open it. To open it, we might use sucker and soldering iron. We need to do it very carefully. Now let's open the screw from the rectifier diode. The company used this screw to make tight with the heatsink. We remove the screw and let's open the rectifier diode from the PCB board. You can see it is a avometer. To check the rectifier diode, we need to select the selector switch at X on of ohms, and all kinds of avometer, you know, there are only two cables, one is red and one is black. We usually use the red cable as a positive leg and the black cable as a negative leg. You can see if we touch on to another, the meter make depression. That means our meter is well. Dear viewers, you can see it is a bridge rectifier diode. It usually have four legs. The left leg is a positive and the right leg is negative, and the middle two leg is input AC leg. Let's check it using a ammeter. We connect the red cable with the positive leg and the black cable with the negative leg of the bridge rectifier diode. You can see the meter make depression. If we connect, that means two legs are good. Now let's check it, change it. Now if we connect the negative cable with the positive leg of rectifier diode and the positive leg of meter with the negative leg of rectifier diode, you see there are no depression of the multimeter. That means it is good. If the meter now also make depression in this two leg, that means it is bad. Now let's check middle two leg, left side two leg. You can see and it's make depression, that means it is good. Now let's again change, it is bad. Now we connect the negative cable with the negative leg of rectifier diode, it makes depression, that means it is good. Now if we change it and then if it makes depression, then we need to think that it is bad, but the rectifier diode and the meter don't make any depression, that means it is good. We checked the rectifier diode, you see, and as a result we got it is a good rectifier diode. Now let's reconnect it with the PCB board. After reconnecting the bridge rectifier diode, we need to check the MOSFET. Now connect the screw with the bridge rectifier diode. Now let's solder it. Now we need to open the MOSFET. Now we open the screw. Now we might check it using a ammeter. You can see it is a MOSFET. Its number is H20R1203. Now let's check it. Between the three legs, there are only two legs that makes depression. If the other legs make also depression, that means the MOSFET is bad. You can see I use positive leg on the middle leg of MOSFET and the negative cable of right side leg, and the meter make depression. Now if we change the cable, then the meter don't make any depression, but this time if the meter make depression, we think that the MOSFET is bad. At first we check bridge rectifier diode and now we check MOSFET. both of these are good. So now we can reconnect the MOSFET with the PCB board. Now dear friends, let's reconnect the MOSFET with the PCB board. Now connect the screw with the MOSFET and the heatsink. And now let's soldering the MOSFET with the PCB board. At first we check MOSFET and the Bridge Rectifier Diode, but both of them are good. As a result, we need to check the SMP section of the PCB board of induction cooker. Let's start. In the SMP section, there are also 4 diodes without a general diode. Let's check the diode. At first, we need the diode using a sucker and a soldering iron. Let's open the diode from the PCB board using a tweezer. In the SMP section, we can see there are only 4 diodes. Let's check it using a ammeter. You can see it is a diode. It have 2 sides. One side is white and the other side is black. We know the white side is positive side and the black side is negative side. Now if we connect the positive cable with the positive side of diode and the negative cable with the negative side of the diode, it will make depression. So that means it is good. And if we change the cable and then if it make depression, we can decide that it is bad. That means it is a bad because the both side of the diode make depression. Let's change it, and the other one we can check now. You can see positive cable at positive side and the negative cable at negative side. Now change it. You can see the meter don't make any depression. That means the diode is good. Now the other side, positive cable at positive side, negative cable at negative side, it makes depression. Now let's change it. It don't make any depression. That means it is also good. Let's change it. Let's check the last one. This time the rules are same. Positive leg at positive side, negative leg at negative side makes depression. Let's change it. It also makes depression. That means it is bad. We got to bad and to good. Now replace the bad diodes. We need to use 2 good diodes at this place. You can see there are 4 diodes, 2 are old, and we use 2 new diodes at that place. Now let's connection the diode with the PCB board. Let's solder the diode. Now we need to remove the extension part of new diode legs. We change to diodes. Now we check the induction cooker board. We change to diodes. Now let's reconnect the all equipment of the induction cooker board. For checking, we do not use any screw. Let's reconnect the sensor with the PCB board. Now connect the cable of cooling fan with the induction cooker PCB board. Now let's connection the panel board cable with the PCB board of the induction cooker. We're just now checking it. For that we do not use any screw. After repairing it is our first time checking, so we might use this socket for checking. Let's check it. Wow, you can hear the beep sound of the induction cooker. We push the power switch of the induction cooker. You can see there have to have been light. At first when we see the induction cooker, they don't have any power, but now we can see the power of the induction cooker. Our induction cooker AC cable is connected with the series socket. So if we connect the series socket, the induction cooker don't make any heat, so we must need to change the plug. So I have to replace the plug series socket to AC socket. Now we put some water on the pot. Now we push the power switch. It is heating, you can see. Thanks a lot for watching these videos. If you like these videos, please like, comment and share. Don't forget to subscribe my channel. And if you have any question, you can make any question in the comment box.